Oh, it does.
Okay, so today we will again. So, have you got any doubt in any of the topic from your end?
No.
Okay, so I
Like
will.
the topics we did last time, right?
Yeah, so we have to revise the last portion, and I told you that
Yeah.
there will be a test for saying the prime numbers in 15 seconds. So, are you ready with
Uh,
that?
yeah, I'm ready. I'm not sure if I can do it in 15 seconds, but I can definitely memorize the numbers.
Okay, so just give me a minute.
Is there any way I can get like a bit more time or?
It's okay. Okay, so your time starts now.
Okay. 2, 3, 5, 7, 11, thir- 13, 17, 19, uh, 23, 29, 31, 37, 43, 47, 49,
49 is not a
50.
prime number. 7 into 7 is 49.
Oh, yeah, yeah, sorry, sorry, sorry. Okay. Uh, 53, 59, 61, 67, also 71, 73, 79. No,
Yes.
yeah. Okay. And then 83, 89, and 97.
Very good. But we're taking a lot of
Yeah.
time.
Yeah,
You
I'm
have to.
not good with it.
No, you have to. So you can speak fast. So I think if you have to more focus on it, you can think of the numbers. So there are only four kind of numbers. You see the number ending with in the apart from the first row 2, 3, 5, 7, 11, 13, 17, 19. Just say this. You can see that there are only these four kind of numbers which are prime numbers. The number ending
Yeah,
with 1, 3, 7, and 9.
yeah,
Then you have 23 and 29. You see the pattern. Try to see the pattern. If the number is ending with 3, it is ending with 9. If the number is ending with 1, it is ending with 7. So 23, 29. The gap is 6, 31, 37. Then again you have three numbers. So 41, 43, 47. Then again 53, 59. Then 61, 67. Then again 71, 73, 79. Then 83, 89, and 97. These are the 25 prime numbers. And you have to be
yeah,
faster in the image. See, if you are taking time to think whether the number is prime or not, you are just wasting the time. That can be calculated by dividing it by 3 or 7.
yeah. And also, I'm not like, whenever I try to speak really fast, I end up messing up. So that's also one reason why I can't
So you look
say
at it
everything.
and say fast. Let me see if you can look at the numbers and just say fast.
Okay.
Okay, just so can you see all these numbers?
Yeah.
Okay. So look at the numbers and say fast. Your time starts now.
Okay. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 40, 41, 43, 47, 50, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97.
Okay, again you have to say again. So you have to complete in 15 seconds. Your time starts now.
Okay. 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97.
Good one. Very good.
Yeah.
So just practice this again. Not now, but after the class you can practice again. Okay, you have to be well
Okay.
versed with this. And without looking at it, you have to say like 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, 97. Like this. Okay. And what about the divisibility rule? You know the divisibility rule of 2?
Yeah.
Tell
So any number that ends with two, like any number that ends with an even number can be
Okay, so the
divided
number
by 2.
ending with 0, 2, 4, 6 or 8 are known as even numbers, and they are always divisible by 2. What about the 3? What about the divisibility rule of 3?
Anything with a digital sum of 3, 6, or
Okay,
9.
just give me a minute. I have to switch off one motor.
Okay. Coming in. Right in the middle. Right middle.
Okay. Yeah, tell me, what is the divisibility rule of 3?
Any number with a digital sum of 3, 6, or 9.
Very good. Good one. And while doing that, you don't need to add the numbers 3, 6 and 9. Okay.
Yeah. Wait, hold on. When you're doing digital sum, you said you don't need to add the numbers 3, 6, or 9.
Yes.
Oh, I thought it was only 9.
You just tell me any 6-digit number.
6-digit number. 1,000, like 1, 3, 5, 6, 7, 8.
Okay. Now let us see, let us suppose that we have been asked to find whether this number is divisible by 3 or not. So how to do it? So I don't need to add this 3, this 6, 1 plus 5 is 6. So I will just add 7 and 8, which is 15. Again 1 plus 5 is 6. So yes, this is divisible.
Oh, yeah. Okay.
Can you see that?
Got it.
I
Yeah,
don't
yeah.
need to add this 3. I will not add this 3. I will not add this 6. I will not add 1 plus 5, 6. The
Yeah,
only
got
number
it.
that I will add is 7 and 8. And what is 7 and 8? 7 plus 8 is 15. Again 1 plus
Yeah.
5 is 6. So if it is 6, then I don't need to add it. So the digital sum is 6. So this number is divisible. Alright.
Yeah, okay. Yeah.
What is the divisibility rule for 4?
Any number the last number should be divisible by 4 of
I didn't say that. That is for 2.
last digit of a number.
No.
What?
How can you say last digit of a number is divisible by 4?
Or no, like I thought that was a simpler version. I know another version, like the last 2 digits, if they're 0
Yeah, last
for
2 digits.
the
Yeah, yes, yes, yes. That is the
yeah,
divisibility rule for 4.
I was just saying the simpler version, but I can say like my version if you want. It's a little long, but
What's your version of saying that? Tell me.
uh any number like the last 2 digits of a number, if it's 0, 4, or 8, the number before that should be even,
Okay,
and the last 2 digits are 2 or 6, the number before that should be odd.
very good. So we say the divisibility rule of 4 is that the last 2 digit must be divisible by 4. The statement is like this: if a number is if the last 2 digit of a number is divisible by 4, the whole number is divisible by 4. But how to check that? So to check the last 2 digits, if the last digit is ending with 0, 4 or 8, the previous digit has to be an even number. And if the last digit is ending with 2 and 6, the previous digit has to be an odd number.
Okay.
Then the divisibility rule for 5 says the last digit must be 0 or 5.
5.
Very good. What about the divisibility rule of 6? You know what is the divisibility rule of 6?
6, like if the number ends with 6 or 2.
Hmm? Every time you say the number ends with, the numbers ends with only is the case of 2. It is not in any other case.
Okay.
Okay, for other case there are different divisibility rules, different statements. For 3 it is the sum of the digits, the decimal sum must be 3, 6 or 9. For 4 the last two digit must be divisible by 4. For 5 the last digit must be 0 and 5. For 6, what is the divisibility rule of 6?
The last digit, like, it should end with 2.
No, how
You
can
said?
you say 2? What about 18?
No, I thought that's what you said.
Okay.
What?
No. So first of all, we have to understand to find the LCM of a number. You know what is LCM?
Least common multiple.
Very good. How you find it? For example, if I say what is the least common multiple of 30 and 45? Find LCM of 30 and 45. How you find it?
We find like 5. It's 5. So
5 is the
we
highest
find,
common factor. I'm asking about least common
wait,
multiple.
I think I need like a revision because I did that in 5th grade a long time ago.
Okay, so right now you don't remember how to do it?
No.
Okay. So then we will come to that, but before that, I would like to make you aware about the exponents. Let us write some values of the exponents. You know what is an exponent? You know?
Yeah.
Tell me.
Exponent, uh it's like squared kind of
Very good. Good one.
to the power of
So,
2.
okay. So if I write a to the power m, this is read as a raised to the power m. Okay, if something is written like this, that is in the superscript, so we read it as a raised to the power m, and it means a is multiplied how many times? M
M.
times. A is multiplied how many times? M times. And A is known as base, and M is known as exponential power. Okay,
Yeah.
a to the power m is read as a raised to the power m. It means a is multiplied m times, and a is known as the base, and m is known as the exponential power. Or in short, you
Okay.
can write exponent. You can write this. Please write this down.
Yeah.
So we need to learn some of the exponential values today.
Melalui TikTok. A. Okay.
Done?
Yeah.
And why do we write exponent? To save the time, ink, money. Okay. So for
Yeah.
example, suppose somebody asks you to write 13 plus 13 plus 13 plus 13, and they will ask you to add it 100 times. How many times?
100.
So you say, why are you doing that? Why not to write like this? So can you see the difference between the two? Here, how many? Suppose I'm putting some effort in writing it down. It requires
Yeah.
energy. So I'm saving that energy just by writing these two. Can you see that? So
Yeah.
the same goes with the exponent as well. If you've been given to write 2 to multiply it 5 times, 1, 2, 3, 4, 5, rather than writing 5 times 2, you just need to write two numbers, 2 raised to the power 5. So it saves time, it saves energy, it saves ink as well, it saves everything. Okay,
Yeah.
everything is commerce. So you have to go along with this, and you have to remember some of the values of the exponents. Understood why the exponent is being used? To save your
Yeah.
time, energy and ink. Now let us do some exponential values which will come in your future as well, which might be coming in your past as well. And apart from that, there will not be any value that you should remember. Okay, so the one that I'm telling you, you have to remember all the values. So it starts with 2, and I want you to start writing along with me. So first we
Okay.
will start writing for 2. 2 to the power 1 is 2. 2 raised to the power 2 is 4. 2 raised to the power 3 is 8. 2 raised to the power 4 is 16. Then 2 raised to the power 5 is 32. 2 raised to the power 6 is 64. 2 raised to the power 7 is 128. 2 raised to the power 8 is 256. 2 raised to the power 9 is 512. 2 raised to the power 10 is 1024. 2 raised to the power 11 is 2048. 2 raised to the power 12 is 4096. Done?
Yeah. Done.
So see, this you should take it as your benchmark. When I say benchmark, if somebody will ask you while you are in a sleep as well, okay, what is 2 to the power 5, you should be in a position to remember, okay, it is 32. So make a benchmark, and then all other values can be found using the reference value. So I hope that you already know 2 square is 4, 2 cube is 8, 2 to the power 4 is 16.
Yeah.
So 2 is multiplied 4 times. So immediately you can say, think of it as 16. Now 5 is 32. So how I remember 5 is, I added 3 plus 2. So 3 plus 2 is how much? 5.
Wow.
So I linked it with 5. If somebody asks you what is 2 to the power of 5, I say it is 32, because 3 plus 2 is also 5. And then if somebody asks you what is 2 to the power 6, I double it. I just double it. So what is the double of 32? 64.
Yeah.
If somebody asks you what is 2 to the power 7, since I remember this as well, I can say it is 128. Similarly, 256. Then the next benchmark is 2 to the power 10. What is the next benchmark? 2 to the power 10. 2 to the power 10 is how much? 1024. It is 1024.
24.
And then, so if somebody asks you what is 2 to the power 11, sometimes it may come in your life. So you will say 2048 and then 4098. Just double it. So these are the two values between which all other values will lie. Alright.
Yeah.
Now coming to the 3. So we have to remember the 6 powers. So 3 to the power 1 is 3. 3 square is 9. 3 cube is 27, 3 to the power 4 is 81, then 3 to the power 5 is 243, 3 to the power 6 is 729. And for this we have a benchmark. The benchmark is 3 to the power 4, which is 81.
Yeah.
This is your benchmark. You should remember this. 3 to the power 4 is 81. 9 into 9. Yeah, 3 to the power has got, see, 3 to the power 4 has got 2 nines. So 9 into 9 is 81. Alright?
Yeah. Wait, let me just. Okay, yeah.
So these values you should remember always. If sometimes you will see 3 to the power 4, you should immediately think of it as 81. 3 is multiplied 4 times, simple. 3 into 3 is 9. And then if you again do 3 into 3 is 9. So 4 times means 9 into 9 is 81. Then 81 into 3 is 243. 3 into 1, 3, 3 into 8, 24. Then 243 into 3, 3 into 3, 9, 3 into 24, 72. So 729. Alright?
Yeah.
Now for 4. So 4 to the power 1 is 4. You see here. So what is the square of 2? Means the double of 2 is half of 4. See, 2 to the power 2 is 4. So 4 to the power 1 is 4. Now you see 2 to the power 4 is 16. So what is half of 4? 2.
2.
So 4 square is 16. Again you will see 2 to the power 6 is 64. So what is half of 6? 3. So 4 cube is 64. Similarly 4 to the power 4 is 256 because 2 to the power 8 is 256. Similarly 4 to the power 5 is 1024, which is 2 to the power 10. Again 4 to the power 6 is 4096. So these are the values which can be remembered using these values only.
Got it.
Are you getting it?
Yeah.
Now, now 5 to the power 1 is how much? 5.
5.
5 square is how much? 25. 5 cube is how much? 125. 5 to the power 4 is how much? 625. 5 to the power 5 is how much? 3125. 5 to the power 6 is how much? 15625. The power of 5 is very easy. I think 5 square you might be knowing it, 25, 5 cube you must also be knowing it, 25 into 5 is 125 is easy. The only problem that you can have is the last three numbers. And it is easy if you remember it, if you look at it carefully, you see that it is 625, just 6 is being added, and then instead of 6 you are adding 31, and instead of 31 you are adding 156.
Oh, yeah.
Okay,
Yeah.
can you see that? Just a
Yeah.
single number is being changing. So you see 1 into 5 is 5, so it is approximately 1 more than 5. Then 6 into 5 is how much? 35. Sorry, 6 into 5 is 30, so it is 1 more than 30. And then 31 into 5 is how much? 155, so it is 1 more than 155. Can you see that pattern as well?
Yeah.
See, here the previous number is 0. So 0 into 5 is 0 and you added 1 to it. Then 1 into 5 is 5 and you added 1 to it, 6. Then 6 into 5 is 30 and you added 1 to it. Then 31 into 5 is 155 and you added 1 to it. So you got 156. Are you getting it? So you can see that pattern. Every previous number is multiplied by 5 and 1 is added. So these values you should remember. Write it down. The power of 5 up to 6.
Yeah. Alright.
Done?
Yeah.
Then 6. 6 into 1, 6 to the power 1 is 6. 6 square is
Okay.
36.
Oh, all right. 25 and 5. Because 25 is where it starts. 25, 25.
It did not say that.
Where's the benchmark number in 4 and 5?
Okay, so the benchmark number is 4 cube 64. For 5, you can remember 5 cube is 125. Most of the numbers you will find this. Many a times you will see these numbers. 4 cube is 64 and 5 cube is 125.
Okay.
Okay. For
Yeah.
6, you can remember this value. 6 cube is 216.
Yeah. Let me just write that down real quick.
Okay. For 6, you
So
have to
is
for 6 you have to remember only 6 to the power 4, not more than that. That's fine. After
so
that
is
you
he supposed to remember all these numbers?
yes sir, he is supposed to remember all these numbers.
Okay.
All the numbers that I am making him write down, because most of the times he will often see that these are the numbers, same numbers that will come in his life in the most of the calculations. Apart from
Okay.
this, there will not be any number.
Hmm.
Okay, for 7. So 7 also you have got to learn 4 numbers. So 7 to the power 1 is 7. 7 square is 49. 7 cube is 343. And 7 to the power 4 is 2401. Now the benchmark number for 7 is 343, and it is just 100 more than, if you see this, it is 100 more than 243, which is 3 to the power 5. So most of the students get confused between these two numbers. So you have to play smartly. How I remember for 7 cube? So see, it is cube. So what is 3 plus 4?
7.
And what is 4 plus 3?
7.
So you can remember like this: 3 plus 4, 3. 3 plus 4 is 7, 4 plus 3 is 7. So it is 343. Are you getting it?
Yeah.
And it is 7 cube. Again 7 to the power 4. So what is 2 plus 4? 6. And 6 plus 1 is 7. So you can remember like that as well. To 24 January. I remembered it like 24 January. It is 2 days before the Indian independence. Indian independence is on 26 January. So 7 to the power 4 is 24 January. 2401. Are you getting it?
Yeah.
Okay. Now for 8. So 8 to the power 1 can be remembered using now cube. You see this? Any power of 2 of 3 is equal to 8 to the power 1, because 2 cube itself is 8. So no need to remember for 8. If you remember for 2, 8 can be found out. So 8 square is what? 2 to the power 6. You compare it. 2 to the power 6 will be 8 square.
Yeah. 64.
Yeah, so 64. Now 2 to the power 9 will be 8 cube. So 512. And 2 to the power 12 will be 8 to the power 4, 4096. You will find that the same numbers are coming many a time.
Yeah.
The same numbers are repeating for 2, 4 and 8. Now for 9, you just need to remember 3 values. So 9 to the power 1 is 9. 9 square is 81, which is also 3 to the power 4. And 9 cube is 729. So you will find it is a very important number, 729. You will find this number many a times in your life. 729.
Yeah.
Alright. So you have to remember all these values. We will have a test on
Yeah.
some day. Probably the coming Saturday I will
On
send you.
Sunday?
Yeah,
Sunday.
probably
Sunday.
next week, the same day, your Sunday only. I will give you some time. So I will take a combined test for the prime numbers. Okay, because I want you to be thorough in prime factorization actually. This is all
Yeah.
why I am doing. I want you to do good in prime factorization. Prime factorization means, so you have written all this?
Yeah.
Okay. So why this is
What's
required?
the benchmark number in 8?
What
Can
sir?
you?
It didn't.
What is the benchmark number for 8?
4096, you get it in 12, 2 to the
Mm-hmm.
power of 12. 512, you get it to the power of 12. No, because this is like the whole benchmark, basically.
Whole benchmark?
No,
No,
no, it's not like that. Look,
Let's see.
So that you can keep it as your benchmark. 8 cube is 512.
So is there a way to like tell, like find out which is the benchmark than like memorizing? How are you like finding it out?
So the benchmark sir, it's my own made benchmark, sir, because I just resemble how to remember a particular thing. For example, I can relate this 3 plus 2 5 and this 5,
Okay.
and up to 2 to the power 4 everybody remembers already.
Mm-hmm.
Suppose you should have a reference point from where you should compare and remember all other values. You can't remember all the values. So if you have a benchmark, then the next value can be compared with the previous value and you double it and you immediately get it. And over the period
Mm-hmm.
of time, you do a lot of questions based on that. So automatically it is in your mind. Then you don't need a benchmark as well. For starting, he needs a benchmark, but after sometimes he is doing a lot of questions based on that. He will just by looking at the number, he will say, okay, this value is this.
Mm-hmm.
So right now that I have learned all these values, so I don't need a benchmark. Immediately I will set the pace. If you ask me any number from here, just in 2 seconds I will tell you the value. But for him,
Mm-hmm.
he has to remember it. So right now he should have a benchmark. Okay, this is the value that I will never forget.
Mm-hmm. Okay.
And then based on this, he will compare the next values and he can. So for example, it is ending with 6. So the number starting with 6 is 64 for 2. So as soon as
Okay.
I hear 2 to the power 6, I say 64 because 6 and 6 merged with me. As soon as
Mm-hmm.
I see 5, 3 plus 2 is 5, so I say 32. Then for 7, I calculate with this. I know that this is 64, so double it. So this is how I make it. You can make your own as well. It's not
Okay.
like that you follow me. You can make your own benchmark. Okay, this is up to where I can remember easily. No need to mug it up. But from here, I need some problem. I can face some problem. So this is what I should remember.
Okay. Got it.
Okay.
And like, what is the reasoning behind remembering prime numbers? Like,
Okay. So for example, sir, what happens is suppose he is getting this. Uh, in the future, what will happen is suppose the question will be given to him like this under root of 76, and it is a sheet in the IXL as well. To simplify this, that is also there in this particular questions like trigonometry. In the trigonometry, let us say that this particular number is given as 17 root 2, or it is given as under root 68, 2 root 17. Okay, let us suppose that this is given as 2 root 17 and this number is given as 2 root 8, 2 root 2, and you have been asked to find AC. So what the student will do, he will do the square of 2 root 17 first, and then he will do the square of 2 root 2 first, and then he will add them, and then
mm-hmm.
it is like 4 into 17 which is 68 and 2 root 2 is 8, so it will come out as under root 76. So if the student knows that under root 76, so prime number is 19, it is divisible by 19, 19 into 4 is 76, immediately he will be writing 2 root 19. Or else there will be another student who will be writing here 76, he will be doing 2 into 38, then he will be doing 2 into 19, then he will take one step under root 2 into 2 into 19, and then he will write 2 into root 9.
Mm-hmm.
So it all
Okay.
saves us time. So that's why these are the basic calculations which will be required till grade 12. I teach in grade 7 to all my students because in the 7th the exponent is being introduced.
Mm-hmm. Okay.
So the prime factor, every question involves prime factorization only. If you need to simplify, you just need to by which number it can be divided. So if you know the divisibility rule, then only you can divide it. And the divisibility rule is done for only prime numbers as well. 2, 3, 5 and 8. 8 is not a prime number. So 2, 3, 5 is fine. If you know the divisibility rule of 2, 3 and 5, that's fine. For 4, it will help you sometimes, because why I'm emphasizing on 4. So for example, suppose you get a number like 104. So I know this is divisible by 4. So immediately I will write 2 into 51. 2 root 51. Sorry, not 51, 26. So there is a chapter known as square and square roots, in which you need to simplify the numbers. The square root. No need to write like this. This is not the right way of writing a number. So if you know that this can be divided by 4, so automatically you can take 2 outside. As of now, I don't know whether you know what is under root, square root. You know about square roots?
Yeah, I know about squares, but no underroots.
Under root is
No,
the other way of saying square root. Under root and square root are same. They are the same thing.
Okay.
Okay. So this is where it will be required. Okay.
Okay, got it.
Now let us say what are the laws of exponents.
Want to take a break?
No,
You want to take a break?
no, it's fine.
Okay.
Tell me how many law of exponent you know. Laws of
Laws
exponent. Yes.
so far, I mean,
Any law you know in exponents. How to calculate it faster.
no, those no. They never taught us that. And
Okay, so there are 7 basic law of exponents. So the first 2 law you can write along with me, based on the same base. The first 2 law is based on the same base. So it says that a to the power m multiplied by a to the power n is actually equal to a to the power m plus n.
to the
And the second law says that a to the power m divided by a to the power n is actually a to the power m minus n.
uh, well, could you please explain
Yeah, I am explaining
two
it.
again?
Don't worry. Yeah. I will explain. Don't worry. I just wanted to write it
Okay.
first.
Oh yeah. Hey, big.
That's m minus m.
Oh, m minus n.
The multiplication is m plus n. When it comes to division, it's m minus n.
Okay.
Okay. Done?
Yeah.
Okay. Let us suppose you have been asked what is. Let us suppose that you have been asked what is 8 into 128. So it will take time for you to multiply, right?
Yeah.
There is other way of doing it. So can you tell me what is 8 as a power of 2? It is 2 cube. Are you getting it?
8 as a power of 2?
Yes.
Oh, yeah.
Just
Got
now
it.
I taught you. And what is
Yeah.
128 as a power of 2? It is 2 to the power 7.
Okay.
So what does it mean? It means that 2 is multiplied how many times? 3 times. Don't write it. Just understand first.
Oh,
So what
okay.
is 2 to the power 3 means 2 is multiplied how many times? 3
3
times.
times.
And 2 to the power 7, what does it mean? 2 is multiplied how many times?
7 times.
So 1, 2, 3, 4, 5, 6, 7. Now overall if you see 2 is multiplied how many times?
And online. I mean, no, sorry, 10. I was
10
looking
times.
at the other one.
10 times. So what has been changed? 3 and 7 are being added.
Yeah.
So if you have the base same, you can see the base is same here. If you are multiplying two numbers whose base is same but the powers are different, the final answer will have the sum of both the powers. And you know what is 2 to the power 10? 2 to the power 10 is how much? 1024.
Okay.
So looking at like this, the number looking like this, it is easier to calculate. Now you might be thinking, sir, I can multiply this and I can find the answer. Okay, fine. Let us suppose you have been given 32 into 128. Now, will it take time for you now?
Yes.
And you might be given 64 into 64. So it will take some time. But now what you can do is, you can write this as 2 to the power 6. This also you will write 2 to the power 6. You can add them, so you will get 2 to the power 12, which you already remember now. It is 4096. So the calculations will become much easier. Are you getting it?
Yeah.
Now same goes with the division as well. So somebody asks you what is 3 to the power 8 divided by 3 to the power 3. So a person will multiply 3 8 times. Is it possible to multiply 3 8 times? That is not a good idea actually. So rather than multiplying 3 8 times, why not to subtract the 3 from 8? So you will have 3 to the power 5, which is 243.
43.
So rather than doing lot of calculations with the exponent and the law of exponent, the calculation will become much easier, much faster. Are you getting it?
Yes.
So understood the two laws. You can write one example as well for both of them.
Okay.
You see how it is being subtracted? Here 3 is multiplied 8 times. In this case, you can see 3 is multiplied how many times? 8 times. And the bottom will 3 multiply 3 times. So 3 will get cancelled out. So you will be left with only 5 threes. The 3 threes from the top will be cancelled from the 3 threes from the bottom. See, if you have a same number in the denominator and you can cancel them. Are you getting it?
Yeah.
So the same thing is being done here. So this is like the two laws.
Okay. Can I real quickly write down the examples?
Yeah.
Okay.
Okay. The next two law is based on the same exponential power. Okay, the same exponential power. Or in short, I can write same power. So the third and the fourth law. It says that if two numbers are having different values but the same exponential power, why not to multiply them first and then raise the power? Same goes with the denominator. So they say why not to divide the number first and then make a common power. So now you can see the number is multiplied first and the power is made common to both of them. So these are the next two
Yeah.
laws. Same power. Now the power is same. In the first two cases the base was same. In the next two cases the power is same. And I will show you how it will help you in the quick calculations. Now time
Okay.
for another, yeah, please write it down. And then you will see a very beautiful thing now happening.
The explanation is still the time. Let us rewrite it.
Okay. Yeah.
I will not get the concept of the time.
Okay. Now suppose I ask you, can you tell me what is 128 into 125? Yeah. Will you be able to tell me this in let us say 10 seconds?
No.
No, but right now you can do. See how. Now see the power of power. Can you tell me, as it 2 raised to the power, what should I write? 128.
So for the
120,
power,
yeah. 2 is what power is 128?
7,
7. Very good. And what is the power of 5 I can write for 125?
3.
3. Now this 7. So if I want to break it into 3, can you tell me in what number I can break it? The 7 can be broken down into 2 addition of sum of 2 numbers. Can you tell me the 2 numbers?
Oh yeah, 3 and 4.
4 and 3, right? Good. 3 and 4. Now you see I have done the first law. I broke this down 7 into 4 and 3. Are you getting it? The first law I make use of it. Now I am
Yeah.
making use of the third law. What is 5 into 2?
5 to 2, 25.
5 into 2 is 10, my dear.
Wait, oh, I thought you were asking for the exponents.
No, no, no. 5
Like,
into 2 I am asking. What is 5 multiplied by 2?
oh, like, 10.
10. So it will become 10 cube. Are you getting it? It will
Yeah.
become 10 cube. And 2 to the power 4, as I already taught you, is 16. So the answer is going to be 16,000. It might be
Yeah.
looking you a tougher part, but it can be done in just 5 seconds.
Yeah.
Are you getting it?
I mean, not too much. I think I still need a little practice on this, but
Okay, don't worry. I will make you practice on this right now. So can you tell me what is 2 into 5?
10.
Okay, you keep writing. Can you tell me what will be 2 square into 5 square?
2 square. 2.
You use the third law. The power is same. So you multiply the number first. What is 2 into 5?
2 into 5. 10.
So 10 square. Are you getting this?
Oh, yeah.
Can you tell me what is 2 cube into 5 cube?
10 to the power of 10
3.
cubed.
Yeah. What is 2 to the power 4 into 5 to the power 4?
10 to the power of 4.
What is 2 to the power 5 into 5 to the power 5?
10 to the power of 5.
You know what is 10 to the power 2 written as? How many zeros you need to write? The same power. For every 10, if I write 10 to the power 2, what does it mean? That 10 is multiplied how many times? 2 times. So 1 is followed by 2 zeros. So the power gives you the number of zeros. Are you getting it?
Yeah.
Now initially, if suppose I ask you what is 16 into 625, will you be able to tell me quickly? No, nobody can tell that. But right now you see that this is this and this is this, and immediately you can tell me, sir, it is 10 to the power 4 actually.
Yeah.
Okay, before remembering all these numbers with this, linking with these numbers, the table was found to be much difficult. Suppose I ask you what is 8 into 125. It will take it will take just to multiply something, but immediately now you can see this is 2 cube, this is 5 cube, so it is going to be 10 cube, which is 1000.
Yeah.
Are you getting it?
Yeah.
So write it down.
Okay.
So some values you just need to remember, like this, the one I have written for you. You can go up to 2 to the power 6 because I made you remember up to 5 to the power 6. So you can write like this as well. 2 into 5 is 10. 4 into 25 is 100. 8 into 125 is 1000. 16 into 625 is 10,000. Then 32 into 3125, it is 100,000. Then 64 into 15625. It is 1 million. So this is the power of third law. And if you can play around with the first and the third law, you can do any calculations.
Should I write down what you just wrote down too? Like on the left?
Yeah, please write it down.
Just copy. And if you get any doubt, ask.
Yeah.
This is the same different form of writing this. Okay, the exponent.
Yeah.
This is the exponential form. This is the expansion form.
Yeah.
Honestly,
It did right scroll, I wonder.
it's 100,000.
Yeah, I know. I was just no, there was less numbers here, so I was just saying.
Done?
Yeah.
Okay, now we can play a game. So I will show you how the calculation can be done faster. So just a request, what you can do is you have written the power of 2 up to 12, right?
Yeah.
And the power of 5 you have written up to 6. Now within those numbers you can pick any two numbers. For example, from the power of 2 to the power 1 to 2 to the power 12, you can pick any number, and from 5 to the power 1 to 5 to the power 6, pick any number. Just give me the multiplication, I will show you how faster it can be done. Like for example,
Okay.
you can pick like 8 multiplied by 625. You can give me like this. Just any random number from 2 to the power 1 to 2 to the power 12 and 5 to the power 1 to 5 to the power 6. Any random number. Give one number from 2 and one number for 5. Okay, I will show you how faster you can calculate it. Tell me.
Okay. S- So like 9 times. Wait, what?
Now give one of this number and give one of this
Oh yeah.
number.
512 times 25.
Okay, so
Hmm?
wait, the pen is not working. 512 times 25, right? Okay,
Yeah.
see how it can be done. So 512 I will show you, it is 2 to the power 9, and I can write it as 12800. You can check it on the calculator. So 512 into, say this.
Oh.
So what I did, I removed 2 to the power, I broke this down into 2 to the power 7 and 2 to the power 2, and this 2 to the power 2 and 5 to the power 2 make 2 zeros, are assigned for 2 zeros, and 2 to the power 7 I remember it is 128. So the answer is 12800. You give me some more, let's see how fast we can do. You give me some more numbers. Any random numbers from
Okay.
both the teams.
Yeah. 256 times 64. No, no, no. 56 times 625. Sorry, I was looking at 4.
Okay, 625. So it is going to be 16, 1, 2, 3, 4. This will be the answer. Let us see. 256 into 625. Say this.
Oh.
The same thing is
Yeah.
being done here. You can see the same thing is being done here. So 256 is being broken down into 2 to the power 4 into 2 to the power 4, and 625 is broken down into 5 to the power 4. Now together 2 and 5 is responsible for 4 zeros. Can you see that?
Yeah.
And this 2 to the power 4 is responsible for 16. So immediately I wrote the answer. As soon as you give me the question, immediately I will write. In fact, it is faster than the calculator. You have to write the numbers in the calculator and then multiply. I immediately write the answer. So this can be done from your side as well. The only thing, if you remember the law of exponent and those powers, and these numbers will come many a times in your life. Rather than multiplying them, see how much time it will take to multiply, but how much time I have taken to calculate it. You give
Yeah.
me one more.
Okay. Uh, 4,000. Actually, no. Let's do 128 times 625. And also, can I use the bathroom real quick?
What? How much? 625?
625. Yeah,
Okay.
625.
625. Okay. So this is 5 to the power 4. This is 2 to the power 7. So again, I think we have done this already. So it will be 8 followed by 4 zeros.
Oh.
See this? 128 128 multiplied by 625.
Yeah. Yeah. That's cool.
That everything is cool. You
Two.
just follow my instructions and everything will become cool. The maths is so fun.
Yeah.
Are you getting it?
Yeah. Can I use the bathroom real quick?
Yeah, please.
Okay.
Begin butler. Huh? Begin it. I think he has to like work through this one. This will be overwhelming for him in the beginning till he understands, till he go through these numbers once again.
Yes, sir. And he can practice some of them in the Excel as well.
Okay.
In the Excel, we have a sheet of exponents.
Mm-hmm.
So here we can see it is in grade 8 C. So understanding exponents, initially they will be giving you some simple questions like this. So 37 is multiplied 4 times. So what does it mean? 37 to the power 4. So 72 is multiplied 5 times. So यहाँ पे just you need to fit 5. And this is 2. So just a basic warm up exercise. And then in the next one, they will ask you to evaluate the powers. So what you can do is, you see this in grade 8, in your Excel, in grade 8 you go to C part, exponents.
Yeah.
So understanding exponents, you can do this sheet. This is simple sheet. So 23 and 87. Can you tell me 23 is multiplied how many times? One time. And 87 is multiplied how many times? Two times. So 87 to the power 2. Can you see this question?
Oh yeah.
It will be in your Excel as well. It is the same. So can you tell me what to write here?
2 and 1.
Then for this,
1 and 4.
4. Are you getting it?
2. Yeah.
So why I gain confidence in you, I will show you why. Yesterday there was a 10th grade student, okay, and I was teaching her the same one of the topics known as matrices that comes later that will come in the later stage of your life. Matrices is in grade 11 for you, I think. For ICSE grade it is in grade 10. So while teaching her, I found that there might be some problem in addition and subtraction, so I have given her the same sheet, B25, the one given to you. Can you see how many questions he has done just to complete the sheet?
Oh. 534.
The same sheet. You can see it is the same sheet, B25. Can you see that?
Yeah.
So don't think that it is and she did in 2 hours 16 minutes. Every time she is reaching to 91, 93, again she is doing some or the other mistake, a simple mistake, she is coming back to 81, then 83. So as of now, you have gained confidence in me that the calculations you can do will be good. So rest of the things I will take care of. Are you getting it? So you are good in maths. You are good in maths.
Thank you.
Yes. And even though now you can see again she did it, so 75 marks only this is getting. So I gave her the challenge. So if you can beat my record as well, I will give you a silk chocolate or $2 from my end. So the record is if you can do B25 sheet in 4 minutes.
4 minutes?
4 minutes. That is my record. So if you want something, you have to work hard for it. Let me show you as well. So if you can break my record, I will give you $2 from my end. Let me show you. And it is open to all. This is my record time, 3 minutes 48 seconds. I am giving you 4 minutes.
Okay.
And it is the same sheet, B25. You can check it here. But don't waste your time in doing that, okay? It will hardly be achieved. I have known it. So it will require a lot of experience. And how many questions you have to do? 24 questions. So 4 minutes means 6 questions in a minute. And 6 questions in a minute means you divide 10 seconds for a question. And that too with an accuracy, 100%. If you miss a single question, it will reduce your mark and then your time will be increased automatically. Understood?
Yeah.
So B25 is a very checkful sheet for me. I give it to anybody who is in grade 12 as well because I want to see whether they know the basic BOD mass or not. And in fact, the exponent questions are not there as well. So there is one more sheet for other persons, like you might see that in future. So that is the sheet E, and none of my students has done it yet except one. So that is in algebra, but as of now I think you might not be knowing it. So it is radical expressions. Simplify radical expressions. So it will come in your life. Like for example, what your father was asking me initially, how to write under root 45. So if you know the prime factorization of, if you know the prime numbers, you know the prime factorization of this. So this is 3 square into 5. So you will write 3 under root 5. This is the answer. So this can be done only if you know the prime numbers and you know the exponential values. All right. So remember all the exponential values. I think I can teach you 5 more minutes to teach you 2 more laws. So up to fourth law, it is clear to you?
Yeah. Like,
Okay.
yeah.
Coming to the fifth law. The fifth law is known as power law.
Take it them on the same page so that you can refer it if you want.
The laws is like,
Yeah, this is the law, right? Just use the same color. So you can refer these two laws.
okay, that's awesome.
So the fifth law is power law. The power of a power gets multiplied. If somebody asks you what is 2 cube to the power 3. So there are two ways of understanding it. Either you write it as 8 cube or you write as 2 to the power 9. You see 3 into 3 is how much?
Yeah. 9.
And 2 cube is 8, so either you write it as 8 cube or 2 to the power 9. Both will work and both are equal as well. Are you getting it?
Understood? 8 cube.
Yeah. Can you I understood some of it. Can you explain?
No, you try to understand that.
See,
How did you get it?
there is a base, there is a multiplication power, then there is a bracket, then there is another multiplication power, exponential power, two exponential powers.
Yeah.
So if it is in a bracket and there is an exponential power, the exponential power gets multiplied. This is the law.
Okay. Yeah.
Okay, are you getting it?
Yeah.
For example, if I give you 2 to the power 3 to the power 4, so what will be the answer?
2 to the power of 12.
And you know what is it? You have to remember it.
Yeah.
4096. Now if somebody asks you what is 8 to the power 4, you can immediately use this law and find the answer.
Oh yeah.
And somebody will ask you what is 64 square. It is the same value. Because 8 to the power 4 can be rewritten as 8 square into 8 square. The power 4 has been broken down into 2 and 2, the first law. Can you see that? So making
Yeah.
use of first law, fifth law, second law, all combining together. Understood? So
Yeah.
this is the fifth law. Then there are two more laws. Very easy.
Can I write that one down first?
Okay.
Because I wanted to listen to you before.
Okay.
Okay.
Okay. The last two laws are very simple. Any number to the power negative 0 is 1. Okay. Any number to the power 0 is always 1. Why it is so? Let us suppose 2 to the power 5 is divided by 2 to the power 5. Now if the same number is in the numerator and the denominator, can you tell me what will be the value?
1.
1. Now as per the second law, it will be written as 2 to the power 5 minus 5. Because the second law says that if the base is same, the power gets subtracted. So 2 to the power 5 minus 5 is how much? 2 to the power 0. But the value is actually 1. So any number to the power 0 is always 1.
1.
Now the seventh law. The seventh law says any number to the power negative can be found by doing the reciprocal of that number. You know what is reciprocal? 1 upon. What is the reciprocal of 2 by 3? 3 by 2.
Yeah,
Reciprocal of 2 by
opposite kind of.
yeah, you have to just reverse it. So sometimes you may be given a number like this 2 by 5 to the power minus 2. So when the
So
power is
just
negative, you will do 5 by 2 to the power 2.
oh, okay.
Okay.
So negative.
So when the power is negative, you make it positive just by reversing the number. Reversing means you do the reciprocal of the number.
Yeah.
How to prove this law? Very easy. So suppose I say a to the power 0 divided by a to the power m. So what is a to the power 0, as I already told you?
1.
So actually it is 1 by a to the power m. But as per the second law, the power gets subtracted. So what is 0 minus m? It is negative m. So both the values are same only.
Okay. Yeah, got it.
Now you are good enough to do this sheet. So I want you to practice of your own. The sheet number C1, C2, C3, you can keep doing this until you stuck somewhere. So C1 you can do, C2 you can do, C3 I don't know whether you will be able to do it or not. Variable exponent. So you can try. 4 also you can try. 5 you can leave. 5 I will teach you later on. 6 you can do. 7 and 8. Negative or 0 exponent. So from E1 to E8 you can try, leaving the decimal and the fractional and the variable part. Alright.
Yeah.
You can note it down in your IXL because I can't assign you anything from here.
Yeah, I could just replay the video when I'm doing it.
Okay.
Like,
Okay, fine.
I-
In IXL grade 8, C1 to C8. Write down IXL, IXL grade 8, C1 to C8. And you have to complete up to C19. As of now, you do up to C8, but slowly you will have a you should practice some of the other thing, not to waste your time. So every day you have to do at least 15 minutes IXL. 15 minutes is essential, minimum. If you practice for half an hour, it is more than enough. You will be the topper of your school. If you do 1 hour, then you will be the topper of US. Okay. So
yeah.
1 hour is like I do daily near about 2-3 hours IXL. Not only with me, with along with the students as well. I keep learning on it because it's a wonderful platform.
Yeah.
Okay, so make use of it. It is a wonderful if you do it. If it is just kept, it is not wonderful anymore. Okay, dish is good when you eat it. If it is kept, then there will be some bacteria or the other something or the other will be on falling on that. Okay, so eat it before it dies. Okay,
Okay.
chalo, we'll meet in the next class. Bye.
Yeah. Bye.
Bye.
Thank you.
Welcome.